If you are thinking about starting your journey in AI or thinking about a career change, the world of AI can feel like major buzzwords, right? Also introducing a lot of hype and ambiguity for the freshers or someone looking for a career transaction to the AI. It is likely to get confused about what is what, especially when the terms like generative AI, agentic AI and LLM. So in this video, we're gonna clear up the confusion. We will break down this what is agentic AI and how it is different from the generative AI. You are watching the video from Byte presented by the Santosh. So without any further delay, let's get started. Before understanding generative AI or agentic AI, let's try to get some understanding how AI was used before the LLM era. Right? Before the era of LLM or the generative AI or a GenAI, AI is nothing nothing about the creating, right? But it's more about predicting, right? So everything before the this so-called LLMs and the GenAI, mostly the AI is all about guessing whether that particular sample is yes or no, or classifying into a certain label, or predicting some numbers, right? So that is the reason people used to call that classical AI as a predictive AI or a predictive analytics, right? For example, think about the apps that you use every day, right? The ride sharing apps like Ola or Uber used AI for predicting the ride fare estimates. The system itself needs to estimate the fare amount for a trip based on the distance, time of the day and the traffic conditions and all other set of reasons, right? It will try to predict the price at that particular instant of time, right? So that will be shown as the price to the end user or the customer, right? So one more example, product recommendation in Amazon. What does it do? Here the AI is used for suggesting the correct set of products to the correct set of users out of all million products. So Amazon will have a lot of products, right? So million products. Out of all million products, it will suggest the right set of products. Meaning, if I purchased the phone recently, the algorithm should recommend the required accessories for that particular phone, right? It should not recommend me randomly products like some fruits, diapers or chocolates, right? So that is how the AI was used for recommending the right set of products. And we all know how that was succeeded, right? One more example, for a bank, AI looks at the applicant's credit score, income and loan history, and its job is to just predict simple yes or no, will this person likely to default on the particular loan or not, right? So typically these kinds of problems are usually solved by the data science team for the business, right? For anyone aspiring to become an AI engineer today, this is really your starting point. Mastering into the classical machine learning and deep learning is a non-negotiable skills. It's a bedrock upon everything else is built, right? As we all know, today's AI can generate entirely new content from the patterns it learned during the training, right? Which means AI is not just about predicting anymore, like predicting yes or no or simply predicting some number, but also it is generating the new text, code, images, even videos with single prompt, right? So that is why we are calling it as a generative AI or Gen AI in short, right? Which we are all aware of it, right? So the underlying model responsible for understanding and generating the language is called as large language model, also in short LLM. Think of like LLM is an incredibly advanced autocomplete system which knows how to generate the text from a given input prompt. I'll try to explain how a typical LLM works, okay, in a very high level way. Okay, let's say that if you prompt a LLM like below, something we have given a very basic prompt, something like below, to make a delicious cake, you need, okay, let's assume you have given this to a basic LLM, a very primary LLM, okay, this will be converted into tokens, right? Think of like roughly each word could be a token, also some important, right? Punctuation could be also treated as a separate token. Why? Because this is a language, even the punctuation is really important, right? So once it is once the tokenization is done, this is how it will be like. This is the tokenization for the given prompt, right? Now LLM analyzes the sequence to make a delicious cake you need, right? And calculates the probabilities of next token, right? Given this context, right? It's highly likely to predict an ingredient, right? So how it will predict? So these are the example probabilities. Let's assume it's a very simplified probabilities I'm just considering, right? So it can predict flour as with 65% and eggs with 15% and sugar with 10% and butter with 5%, right? So it can predict n number of words, but it will only pick the top predicted word. So here what is the top predicted word? Flour, right? But how did it know, right? Because during its training process, it has learned that for a given sequence, based on the intent or the meaning, it knows what to predict as a next word, right? Let's say it picks the flour in this case. So the output, right? The output will be the flour, right? So, this will be appended to the end of the sentence of the prompt that we are given, right? If we observe here, even LLM tries to predict the next label, something like a classical ML or DL algorithm, right? It's a classical DL algorithm. What it do? It will predict the probabilities or the numbers, right? However, this LLM is abstracted from the user, and it's like, that's why it is like pretending like it is generating new text altogether. That's a different story. We're going to discuss more on that when we talk about the LLM internals or the LLM technicality, right? But for now, let's assume that it is generating the words, okay? After this first prediction, it will not stop over there, right? It will generate the subsequent tokens, right? The new token, the recent token which was generated, flour, will be added to the sequence, sequence which the LLM is considering. Now the new input for the LLM is something like this. To make a delicious cake, you need a flour, right? The flour is predicted in n-1. In the previous step, the flour is predicted, but now it is added into the sequence. Now LLM predicts the most probable token given flour as the most recent addition to the context of cake making. Let's say it might try to predict the one more ingredient, but before that it needs to add some punctuation, right? Because punctuation is really important in the language, right? So now the examples probabilities for the next set of tokens could be something like this, very similar to like this, right? So the comma with 70% of probability, or the end with 15% probability, and full stop with the 5% probability, right? So it's obvious that the comma will be the most probable token, and that will be picked up, right? So assume the comma is picked up by the LLM. So the output of the next token is second new token, basically the comma. So if we continue this particular sequence, right, the new input for the LLM, what it will make? The new input for the LLM is, to make a delicious cake, you will need flour and comma as a punctuation that will be also added, right? Now with this context, LLM again tries to predict what is the most probable outcome, right? So here in this case, probably it can predict sugar or some other ingredients, but the sugar it might predict with the maximum probability, it will pick the sugar, right? So similarly, this process continues with the LLM and building the sentence piece by piece by the LLM, right? To make it, so finally, right, by the end of this prediction is done, the final sentence would be something like, to make a delicious cake, you will need flour, comma, sugar, comma, and eggs. Let's assume this is being filled by the LLM. This is how the LLM will try to complete, auto-complete, or try to generate the new text based on the given context or the given sentence, right? So the key takeaway is that the LLM is essentially a highly advanced language prediction system based on the patterns it is learned from the vast amounts of text data, and generates the most statistically probable and coherent continuation for any given input prompt, right? So the same principle will be more or less applied for the other generative AI models, which can generate the code, images, videos, etc., right? So in a simpler way, any LLM can be good at understanding the language and generating the rich content, but LLM itself does not make decisions or trigger the actions. Very important line to understand. Example, let's say LLM can help you to write thousands or hundreds of emails within a short time, but it is your responsibility to route these emails to the correct people or the current customers, right? LLM will not send the mail. You have to send it, or the team who is responsible for sending that emails, they need to send it, right? For an AI engineer, let's talk about the AI engineer now. For an AI engineer, understanding how LLM works or how to fine tune them and how to deploy them, and it's a really critical skill nowadays. So you cannot skip this part, right? So far, we have discussed how traditional AI is excellent at predicting and how generative AI can create a new content like text, code, image, right? We also clarified that LLM on its own, it's a very powerful prediction engine, but does not make decision or take an action in the real world, right? Now let's talk about what is agentic AI. Okay, let's skip the fancy definitions of agentic AI here. So simply to put in, right, agentic AI is a system of agents or well orchestrated bunch of agents, right? That's all, right? So if I tell you about like examples of agentic framework, there are many like LangGraph, LangChain, Google ADK or AutoGen or Crew AI, etc. Right? These are many of them are present. We need to start learning with any one of them, right? I know there are a lot of agentic AI frameworks are evolving a lot. Each and every company is building their own agentic framework, right? But we need to understand the basics of how agentic framework will work. To do that, we need to start understanding one particular framework, any framework which you are as part of your, it's up to the comfort level what you have, right? So I know I've been talking a lot about agentic framework and agents, right? But here comes one more fundamental question. What is an agent in the first place, right? An agent is a computational entity that can work alone to plan and take in certain actions or collaborate with other agents as well, right? Again, each agent might contain the prompts to the LLMs, API integrations and MCP server integration, RAG. Sometimes the agent also contains classical AI or classical machine learning or the deep learning models as well. Let's not worry, we will see an example what kind of problems agentic AI might solve. So example number one or use case number one, consider a case where AI engineer needs to build a credit card fraud detection or fraud transaction detection system for a banking client. Of course, this is a very classical problem. Let's assume that the data scientist team in that particular bank, they have used only traditional AI. The predictive analytics which we discussed earlier of this video, right? So AI engineer or the data scientist could build a system that can predict if the provided transaction is fraud or not. That's all. It's just a classification. It will tell that the given transaction is fraud or not. That's it. Yes or no kind of, right? If it is detected as a fraud transaction, the next set of action might be taken care by some other teams where they might require the manual effort by the humans or some other complex systems, right, on that particular transaction to take necessary immediate action, right? So in the same application, let's say that we also integrated the GenAI. The GenAI might help the give explanation or the interpretation how that particular, how common fraud transaction happen for this given fraud alert, right? So this explanation might helpful for the team who are actually responsible to take the next set of steps, right? So if I use the traditional AI, it will only say yes or no, but if I use the generative AI, it can give some kind of explanation what we can do. That will be helpful for the team who need to address it, right? Now let's assume the same problem is addressed with the agentic AI. If the same problem, the credit card fraud detection system, if it is being integrated with agentic AI, let's assume, then the solution might be like this, right? As there are multiple agents will be under the hood, if one agent can be used to detect the suspicious transaction and the other agent sends the signal to the, the same agent can send the signal to the other agent which can block the transaction immediately, right? And another agent, one more agent, we can also, there are like bunch of agents we just talked, right? And one more agent also we can use to freeze the account of that particular customer, and one more agent can send a fraud alert to the customer. See, all of these above actions are well orchestrated or completely structured and well orchestrated and triggered autonomously without human intervention. One more example we can talk. Let's assume that if I want to build an automobile malfunction detection system, automobiles like cars, I want to build a system where it will detect if there are any malfunctioning units in my car, so that it should show in my car infotainment system. Again, if I use the traditional AI, right, that might report a mission malfunction, meaning if the certain machinery is not working properly or not. That's it. So the traditional AI might show that certain fault is there at certain machinery, it's not working. So up till then it can predict, right? So if I integrate the Gen AI here along with the mission malfunctioning reporting, it could be also capable of suggesting the troubleshooting steps that are required for that particular mission default, right? So that can be achieved with the Gen AI. Let's say if I build this application, if I integrate this with Agentic AI, I can build in such a way that there is a scope. I can build in such a way that one agent might detect the early signs of the mission failure, and it can tell another agent to schedule a predictive maintenance with the service center, and also it might invoke online orders for the necessary parts that are damaged in the online, right? All this without human intervention until the maintenance is completed, right? Everything is handled without any human intervention until the maintenance is completed, right? How this is doing, like I said, each agentic AI might consist of the LLM prompts, right? Sometimes sometimes the agent might contain the classical machine learning or deep learning models. So it also might be integrated with MCP, RAG, etc. Right? So the agentic AI is not just that LLM charts. It's an AI that acts. It plans, uses the tools, and make decisions, and completes the real task, right? Just like a human assistant would do, right? So in future, no doubt, there are many applications that might evolve where agentic AI could solve some routine or repeated or well deterministic workflows, right? If some workflow is too much routine, or it's been repeated and repeated every day, and if that particular workflow is well deterministic workflow, these kind of workflows definitely can be automated with the agentic AI. So that's all for this video. Hope you know, now you know that what's the basic difference between the agentic AI, LLM, and the traditional data science, right? If you find this video helpful, please hit a like button down below and subscribe to the Byte for more such kind of content like this. All right, see you in the next video. Till then, happy learning. Bye bye.